Welcome on the channel. Today maybe a bit shorter, but same boring stuff. Okay, work over final. I don't want to tell what it will be. Are in progress, not enough material to make a new video yet. So today on request, final diagram of this one channel of this amplifier plus comments. Okay, so this is simply single-ended amplifier built on junk parts, including junk transformers, junk speakers for it, etc., etc. So we don't want to fight for every hertz below or over certain range. Of course, always it will be better than worst, and I don't want to keep, the old reel-to-reel recorder range up to 12 or 10 kilohertz. I want to go at minimum to 17 kilohertz. This amplifier was not designed is too big word. I just built it with floating heater power supply. Why we floating? Because usually is floating means it's not connected to the ground of full amplifier. Floating because one of thing I use strange solution to power these heaters of these tubes here, and second because PCF80 working very close to his limit, because there's only 100 volts from heater potential to another potential. It means only 100 volts. Right now on another, from what I calculate, is around 100 volts, so it's just on the verge with floating, not connected to the ground. We have not such a problem. Of course, many people will claim so it's create noise and hum. Not in this case, maybe because the transformer are weak and speakers are also weak. This is what I understand. Maybe I have no right. We have to remember, so usually such a simply amplifier built on basic diagram always work. If not work means we make a mistake in assembly, part are broken, or we overshot with value of component to the just other range. Let's say instead 1 ohm we fit 100 ohms or something like that. So we have to go over the range. Of course it will work well or not well at all, but it should work. A second remark you have to remember, so in tube amplifier transformers limit everything. It means not maybe everything, but like a just the band of the amplifier. So if transformer are weak, you cannot do anything more. Yes, so this is the most important to remember. Because of that, we can make a lot of simplification and don't calculate anything nearly, but we have to calculate something. Follow the diagram. On the input we have like a pot for volume control. I use 50 kilos because with modern sources of signal is no reason to use bigger one. Bigger one only collect junk from the air. We keep the 50 kilo, 47 kilo. If you don't have, you can use of course 100 or 200. It will still work, but can be problems with kind of hum or something like that. Next one. On schematic I make two, not cycles, it's a kind of strange shapes which mark capacitor and resistor and grid leak resistor, and they create kind of high pass filter. It means it's responsible for lower end of frequency response of amplifier. But because we don't fight for every hertz, we make a simply thing. We just choose the grid leak resistors from datasheet of the tubes, Usually they give the maximum value. I choose 2 times 330 kilos. And capacitors, everything from this range, of course not electrolytic. Decoupling capacitor of second grid of PCF, anything from the range from 0.47 up to 1 microfarad will be okay, and it have to be not electrolytic. Grid stoppers. Grid stoppers, in this case, this is the must, because this is kind of, let's call it, modern tubes. Usually anything from the range from 1 kilo to 10 kilo ohm is okay. I use 1.2 because I have a lot of them. Usually in other projects I use from 1 to 2. They have to be, this is important, they have to be assembly as close as to the base socket as we can. In other ways it will not work. Cathode resistors and capacitors. It's similar situation, but these elements are responsible for a few things, so maybe my mumbling will be less clear, if it's clear at all. Okay, the value of cathode resistors usually we take from the data sheets or like a suggested design. If not, we have to calculate something, so we not calculate, just follow the diagram. So cathode resistors of PL83 we just take straight from the datasheet. Cathode resistor on PCF I make with some calculation, so keep this value. And right now bypass capacitors on these resistors. Again, they are responsible for lower frequency, but blah 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 blah, we not fight, etc. So on preamp stage, anything from 20 to 50 microfarad will be okay. I use 22, should be okay. I not check, but should be okay. On power stage, anything from 47 to 100 microfarads will be okay. Right now about resistors. The chain of these resistors over the PCF and resistors over a cathode resistor of PL83 are responsible for current of these tubes. So keep the values. Here we can change something a bit. Let's say if we're talking about another resistors, we can go up or down with few percent up. We can go more because these resistors are responsible for current and they set the operational point of the tube. So if we change it, we moving slightly with operational point, so it will be some changes, but of course, like I said, few percent doesn't make a big difference. Grid 2 resistors. On PCF we have 150 kilos, and on PCL is a RG2, I mark it. Keep the value of this 150 kilos plus minus, because this resistor sets the voltage and limit current on, because like I said, PCF working just on the edge of possibilities, and with G2 resistors, second grid resistor of PCL, we have more complicated situation, because we have to supply the second grid with 250 volts, and also we have to supply the anode of PL83 with 250 volts. But our power supply is not equal, because we lose some voltage on transformer resistance, and here is a lot depend on transformer, because my transformer has a quite huge primary resistance, not impedance, resistance. It means 800 ohms. Usually is much less, 350, 250, 300, something like that. So in my case, the voltage which are lost on transformer winding is much higher than, let's say, in other case. So value of this G2 resistors have to be calculated just from the ohm law. We have to limit from the ohm law with calculation, so current for G2 should be 4 milliamps. So we have our voltage on supply. We know how much we have to lose of this voltage on this resistor with such a current, and we have to calculate the value. So this is the most complicated part of building this amplifier for somebody who don't wanna know how to calculate all elements. Totally true, I don't know either. I know a lot, but not everything. Let's say, question, can we use the different tube in power stage? Yes, we can. Anything what we have to change, this is cathode resistor in this case, plus second grid resistor. And of course, everything depends on our power supplies, etc. I strongly recommend to use the meters, multimeters, when you, because this amplifier should start from the beginning, just from shot, bang, and it should work. But if we made mistakes, it's happened. We can destroy something or somebody, no, let's say something. So if we have a meter, if you have ammeters including in a anode of anodes of both tubes, we know, so everything is okay or something is go wrong. If current starts going too quickly up and cross the value which we found from datasheets, it means something is wrong. We can always switch off, no magic smoke, anything, and we can start looking for mistake. Okay, that's all for today. I back to the workshop. Thank you for watching. If anybody watching it, please consider subscription, like it, and comment. Thank you.